Welcome to my second lecture on iGCSE chemistry. In this session, I'll discuss about the relative formula of mass and chemical formula and chemical equations. Okay. In that this lesson, relative formula mass will be calculated. First, I'll calculate the relative formula masses from relative atomic masses and understand the use of term mole to represent the amount of substance. And also carry out the mole calculations using relative atomic mass and relative formula mass. So what is relative atomic mass? The mass of particular atom compared to mass of an atom of hydrogen. That is relative atomic mass. Relative atomic mass is also the same as the mass number. It's that simple. Yes. Relative atomic mass is total number of protons and neutrons. You see in sodium, there is a 28 number there is the atomic mass number of sodium. Atomic number of sodium is number of protons, which is 11, also electron number in a neutral atom. The relative atomic mass is always bigger than atomic number. Look up the mass numbers of the following elements: oxygen, iron, carbon, lead, iodine, nitrogen, helium, copper, calcium, tin. See, oxygen it is 16, carbon it is 12, iron atomic mass number is 56, lead is 207, iodine 127, helium 4, nitrogen that is 14, copper is 63.5, calcium is 40, and tin is 119. So when an atom join together to form a compound, for example, magnesium oxide is there, we can calculate the relative formula mass of it easily, because mass number of magnesium is 24, oxygen is 16. So sum of these mass numbers is 40. So that is nothing but relative formula mass of the substance. What is chemical formula? Magnesium oxide, if you take, and there is one magnesium and one oxygen symbols we are observing in the formula. H2SO4 if you take, and there's 2 hydrogens, 1 sulfur and 4 oxygens we are observing. Calcium hydroxide, if you see, in that 1 calcium and 2 oxygens, 2 hydrogens are there. Whereas in the case of 2 Na2CO3, there are 4 sodiums, 2 calcium atoms, and 6 oxygens are there. So, when atoms join together, the relative mass how we calculated, like that of, we can calculate the relative formula mass of some of the compounds. If you take calcium oxide, relative formula mass of calcium oxide is 40 plus 16 is 56. Sulfuric acid, that is 2 plus 32 plus 64, 2 is for hydrogen atoms, 32 is for sulfur, and 64 is 4 oxygens, and total is 98. Sodium nitrate if you take, then sodium is 23, nitrogen is 14, and 1 oxygen 16, 3 oxygens is 48. So total is 85. Aluminum hydroxide if you take, aluminum is 27, and OH, total OH is 17. So 17 into 3 is 51. 51 plus 27 is 78. Lead carbonate, PbCO3, in which lead is 207, carbon is 12, 3 oxygens is 48, total is 267. Beware of relative atomic mass, relative formula mass, they are not same. So the mole, what is the mole? You may think that the mole is a very blind animal that lives underground. No, the mole is also a measure widely used in chemistry. Here, 1 mole is the relative formula mass of a compound or relative atomic mass of an element expressed in grams. So 1 mole can be relative formula mass of a compound or relative atomic mass of an element expressed in grams. For example, relative atomic mass of carbon is 12. So the mass of 1 mole of carbon is 12 grams. How simple is that? Yes. Now let us see what is the mass of 1 mole of lead. Relative atomic mass of lead is 207. So that the mass of 1 mole of lead is 207 grams. Let us see let's get a little more clever now. Calculate the mass mole of moles from the relative formula mass. Don't panic in this case. We have an example that is relative molar mass of sodium hydroxide, that is 40 is there. This. So the mass of 1 mole of sodium hydroxide is 40 grams. Then what is the mass of 1 mole of calcium carbonate? The relative molar mass of calcium carbonate is 100. So 100 grams is the mass of 1 mole of calcium. So this is not rocket science. Important equations are there. Study as you go. Number of moles can be calculated by dividing the mass used with the relative molar mass. For example, how many moles are there in 20 grams of sodium hydroxide? So number of moles is equals to mass given in the problem is 20 by 40. It's a relative molar mass. So 20 by 40 is 1 by 2, 0.5. So 0.5 is the number of moles of sodium hydroxide given in the question. We will even rearrange the equation. Yes, number of moles is equals to mass used by relative molar mass, or mass used is equals to number of moles into relative molar mass. We can rearrange it. For example, what is the mass of 2 moles of calcium carbonate? Yes, mass used is equals to 2 moles of calcium carbonate against 2 into calcium carbonate molar mass is 100. So 2 into 100 is 200 grams. So mass of 2 moles of calcium carbonate is 200 grams. Yes, that is correct. Now, let us see the second concept in this lesson is chemical formula and chemical equations. In this, write the word equations and balanced chemical equations to represent reactions studied in these specifications. And also we'll use state symbols. SLG, that means solid, liquid, gas, and AQ for aqueous in chemical equations to represent solids, liquids, gases, and aqueous solutions respectively. Understand how the formula of simple compounds can be obtained experimentally, including metal oxides, water, and salts containing water of crystallization. Not only that one, calculate the empirical and molecular formula from experimental data, and also calculating the reactive masses using experimental data on chemical equations. And finally, we'll carry out some mole calculations using volumes and molar concentrations. Let us see, using chemical symbols. Each element is represented by different symbols, For example, Fe is for iron, Na is for sodium, O is for oxygen. All of these symbols are in the periodic table. We can use these symbols to show molecules of compounds, and they can show us the ratio of different elements which combine to form compounds. Example, H2O, CO2, NH3, water, carbon dioxide, and ammonia. Using chemical symbols, let us recap on what we covered earlier. Is nothing but sodium hydroxide is there. Na is 1 atom of sodium, O is 1 atom of oxygen, H 1 atom of hydrogen. Calcium carbonate, in this 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen. And magnesium nitrate, we have 1 atom of magnesium and 2 atoms of nitrogen and 6 atoms of oxygen. In the case of aluminum sulfate, 3 moles. So 3 times of this one. So 3 into 2 is 6 atoms of aluminum, 9 atoms of sulfur, and 36 atoms of oxygen. Now we'll see equations. Reactants gives rise to products is equation system. In this, sodium plus water gives sodium hydroxide plus hydrogen is the reaction equation. In this, Na plus H2O gives rise to NaOH plus H2. So if you see the equation, left side we have 2 hydrogens are the right side we have 3 hydrogens are there. So that can be balanced by using suitable coefficients before the symbols. And 2 moles of sodium and 2 moles of water gives 2 moles of sodium hydroxide and H2 with the state symbols. State symbol for sodium is S, for H2O is L, for NaOH is AQ, for H2 is G. So state symbols S, L, AQ, G used for this equation. This is the complete chemical equation representation. Now you need to know your state symbols. S is solid, L is for liquid, AQ is for aqueous solution, G is for gas. You also need to be able to write the word equations when required. Recall formula of simple covalent compounds. Write down the formula of simple ionic compounds. Interpret chemical formula of molecules. Interpret symbol equations including state symbols. This is the rules in writing the equations. Simple covalent formula. We have water is the H2O, carbon dioxide CO2, ammonia NH3, hydrogen H2, oxygen O2, nitrogen N2, sulfur dioxide SO2, methane CH4. And some simple ionic formula, sodium chloride, calcium chloride, CaCl2, magnesium oxide MgO, hydrogen hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide CaOH twice, and calcium carbonate CaCO3, aluminum oxide L2O3, iron oxide Fe2O3. So these are the list of simple ionic formula used. Next, writing balanced equations. In this, writing balanced chemical equations can be good or bad for your health. No. This basic rule is a golden rule, that is hydrogen plus oxygen gives water. H2 plus O2 gives rise to H2O. Learning point. Here gases like hydrogen and oxygen are diatomic. They like to go around pairs. So here there must be equal number of atoms of each element on both sides of equation. So here we have the number of atoms in both sides of equations are not same. So if you rearrange them with the suitable numbers, then it will be correct. So there are 4 important steps are there writing balanced equations. First one is write the word equation for the reaction. And also put in the formulae of elements or compounds. Balance the equation, put numbers in front of the reactants and products where necessary. And complete the balanced symbol equation using state symbols. These are the 4 important steps in writing balanced equations. For example, if you take the first one, magnesium plus oxygen gives magnesium oxide. Is a word equation. That symbolic, that means symbol Mg for magnesium, oxygen element O2, magnesium oxide MgO. Now gases like hydrogen and oxygen are dynamic, they like to go around the pairs. So that means this Mg, one is there, O2, 2 atoms are there, magnesium, one is there, oxygen, one is there in the product side. So it's not balanced. So we have to balance it by taking the suitable numbers before this one. So 2 is the suitable number for magnesium, the reactants, and 2 is suitable number for the coefficient of product MgO. So then all the atoms got balanced. Now we have to write the state of the compounds, that is solid magnesium and gaseous oxygen and solid MgO. Okay. Now let's see another example. Nitrogen plus hydrogen gives ammonia. So what equation in this? Gives N2 plus H2 gives rise to NH3. Whereas two nitrogen atoms, two number hydrogen and one nitrogen in product and three hydrogens in reactants. In this case, two nitrogens, before hydrogen, if you put 3 is a suitable number, then it will get balanced in the reactant side, and product side before NS3, 2 is the suitable coefficient. Then all the atoms got balanced with the necessary suitable coefficients. And now nitrogen, oxygen, hydrogen, ammonia, these are all gases in nature. So states are presented with Z as a symbol. So this is the end of this lesson. In this lesson, we have covered relative formula mass, chemical formulae, chemical equations. Okay. So we will meet in the next session with another important thing related to this lesson number 2. Thank you.